And it will be time for Mid-Atlantic to present their city.
Welcome to CityCon 2163. I am Mayor White of Estuaria, and I'm happy you have come to see us as we celebrate our city's 150th anniversary. Originally founded as the model city in stormwater management, the more than 200,000 people living in Estuaria have found even more. I would like to introduce you to Mr. Campbell and Mr. Waples, our two head engineers.
Good day.
Like many of the other cities represented here today, engineering has shaped and continues to shape Estuaria's development.
Estuaria was designed and built as an infrastructure project in order to reduce stormwater runoff and its negative effects on the environment. Well-managed stormwater is important because of our location near the diverse ecosystems of the Chesapeake Bay.
More than a century ago, 70% of pollutants entered water bodies through runoff that flowed freely along impervious surfaces. When the Chesapeake Bay could not reach water quality standards in 2013, the EPA took decisive action.
Their plan was Estuaria. Engineers from around the globe designed our city as the ideal in stormwater management in order to provide a model of healthy interactions between human and nature development. Several solutions were designed to accomplish this goal.
All the technologies mimic nature as much as possible because without human intervention, nature does not have a runoff problem.
A process known as zero development was the first solution implemented.
Zero development integrates buildings into nature by using few impervious surfaces and having little site disturbance. Zero development follows three main principles: increase infiltration, reduce impervious surfaces, and the use of stormwater as a resource.
Pre-engineered living spaces, or PELs, were the first structures used for zero development. PELs were prefabricated, reducing sediment runoff since the site is left mostly undisturbed.
PELs have other features as well. Green roofs infiltrate the first inch of rainwater, unlike traditional roofing, and reinforcement from carbon nanotubes helps support the extra load. Water that is not infiltrated is collected and used for all non-potable needs.
Citizens find Estuaria walkable because of a morphed grid. Many multi-use PEL centers containing life staples keep quarters close and aid walkability. Integration of landscaping creates an easing environment for all pedestrians.
Landscaping plays a major role in zero development. Estuaria has three main levels of landscaping to infiltrate effectively as much water as possible. These three levels are xeriscapes, rain gardens, and managed forests.
Xeriscapes are found throughout Estuaria on its rolling hills. Xeriscapes are landscapes with plants preferring dry soil. Slopes throughout Estuaria's rolling hills are planted with xeriscapes in order to infiltrate as much water as possible and prevent flooding in the lower areas.
Rain gardens are planted in lower areas of our city, since water naturally seeks the lowest levels. Water that is not infiltrated by xeriscapes is collected by rain gardens as a kind of fail-safe system.
Managed forests are found throughout Estuaria. Trees prevent sediment runoff, absorb stormwater, and prevent the heat island effect. A 500-foot forest buffer has been saved along the Bay Cliff to act like a giant filter against any runoff.
Even with all the solutions brought forth by zero development, pollutants further degrade the water quality. Nitrogen and phosphorus, two main pollutants from the bay, cause algae blooms, which resulted in deoxygenated areas or dead zones. In 2076, chemical engineers developed an ingenious method to remove these pollutants from the bay.
When the oil and gas industry crashed in the 2060s, engineers from Estuaria quickly renovated the existing infrastructure to fit the needs of pollutant removal. Ships, seen here on the model, collect and cleanse water through chemical reactions.
Nitrogen is synthesized with hydrogen peroxide, HO2, forming nitric acid. Phosphorus is synthesized with hydrogen and oxygen atoms, forming phosphoric acid. These are collected, and the purified water is returned to the bay.
Creation of acids may seem risky, but specialized one-way capsules, similar to vials of medicine used in the early 21st century, ensure that even in the case of a disaster, acid cannot leak into the recovering bay waters.
Nitrogen is then liquefied and used as a clean fuel for vehicles, while phosphorus is used as a fire-retardant material, stopping the fires before they start.
As the pollutant removal industry grew, so did Estuaria. Soon, PELs could no longer suffice for the growing population. Skyscrapers called eco-towers replaced PELs as the primary unit.
Eco-towers follow the same principles as zero development and mimic trees since they treat and use stormwater.
Green balconies extend from the shaft of each eco-tower to slow down and absorb stormwater. Parks and plazas surround each eco-tower to ensure that 95% of all stormwater is infiltrated.
Rain that falls into parks and plazas is captured into foundation cisterns so it can be filtered and pumped to the top. This water is then used throughout each eco-tower.
Parks and plazas are part of a gigantic green roof over a below-grade retail and transportation hub. This mall layers our business district, with towers above, a magnetic levitation or maglev train system below, and retail in between. The ability to easily get from transportation to work or shopping is an added convenience to citizens.
Our enhanced version of maglev transportation runs through a vacuum tube, allowing for incredible speed. Fast movement of goods and people keeps Estuaria's economy strong.
This is why businesses in Estuaria want an extension of the current transit system to connect us to the Eastern Shore. Civil, geotechnical, mechanical, chemical, and transportation engineers, among many others, have proposed a 3.8-mile bridge crossing the Chesapeake.
Named Save the Bay Bridge, it will be like none other in the world. Acting like an oyster, it will remove sediment and other pollutants from the bay. A filtration system in the towers of the bridge will aerate the water, preventing the former problem of deoxygenation.
Sediment, a pollutant from runoff, can now be removed, helping the Chesapeake's waters and our economy. Many materials, such as heavy metals that usually kill ecosystems, can now be extracted and sold.
The Save the Bay Bridge will have a multi-layer feature, similar to our layered central business district.
Layers will include retail, lab space, public walkways, and common space that can be used for tourism.
Although this bridge will have expensive construction costs, many benefactors have offered funding because of potential to gain wealth from a connected East and West Maryland economy.
Construction of this bridge allows for partial disturbance of the recovering bay waters, a major issue among estuarians.
However, most believe that this trade-off is acceptable because of the likely benefits of the bay's waters and our economy.
Looking back these 150 years, one thing becomes evident. Engineering has shaped our history since the beginning.
Thanks to engineers, Estuaria has become a thriving metropolis, a city where man is reconciled with nature. Thank you for attending.
Are there any questions?
One question that I would have, besides water conservation, what benefits can be derived from stormwater runoff in your solutions here?
Well, as we were talking about in our presentation, we have our pollutant removal technology, which combats the effects of runoff on the bay over hundreds of years before our city. And with that, we've removed nitrogen and phosphorus. But then we've used these pollutants, nitrogen specifically, as an energy source for our city.
Also as an export.
Of all the things that you've learned working on this project, which one of these systems or applications would work today?
I would believe that the 500-foot forest buffer would work today because it's effective in slowing down pollutants such as sediment, and also it makes it more of a holistic approach to the city.
And then secondly, after that would be the PELs. We have done prefabrication, and this only requires a little bit more work in green roof technology to be able to get actual pre-engineered living spaces in a city.
Thank you.
What was the biggest headache? What went wrong?
Well, for myself, I was mostly in charge of creating several of the moving parts, including the water system that we demonstrated earlier. That was a giant headache because often the water would spill, and we had to create this system so it was watertight and wouldn't get the rest of this model that doesn't like water, which we found out without getting it.
Well, for me, I would have to say putting the trees in place and getting them all together because they're derived from a plant called sedum. And what we did was we sprayed it with the solvent and painted it. And it was a big headache because they were so fragile. Actually knocked some over.
Hurricane Lewis over there.
Sure. And I know a difficult part of our project especially was the contours, because since we're in such a contoured land, we had to make sure that the residential area was with the contours while we had the more flatter area devoted to commercial and industry.
In which we used this topographical map.
Thank you.
What skills have you developed during your involvement in Future City?
For me, myself, it was probably mostly team building. We had a team much larger than the three up here. It was approximately 15 people. And it kind of hard to manage that, but we all learned how to work with each other and be able to manage our time. So with our after school, we'd be able to get the most done with just 2 meetings every week.
For me, we had to do a lot of research to this, of course, stormwater runoff, but also how a city works in general. We had to experience different systems, how they integrate, and just basically how a city works within its different zones.
Mine would be zoning of a city, because you just can't have everything in certain places, with SimCity actually really helping. We've been able to show the growth of our city but have it in the area that's most fit for the buildings.
How did you guys approach budgeting for growth in your city?
May you please
What-
repeat that?
Budgeting.
Budgeting.
So early on, we were talking about how the EPA and Chesapeake Bay Foundation would fund this project as a measure to save the Chesapeake Bay from water quality. So this started off as a government project, but then as it grew on, the citizens started to take over, and with pollutant removal technology as a fuel, it's become kind of like a new oil. With exports rising, the entire city would rise, specifically for building the model in actual real life, Louis.
Also, over here, we have the Pels, which were the beginnings of our city. Yeah, I have one.
For
And they faced higher taxes until we had the growth of our city. And in the realism of the model, since most of our materials were recycled, such as the ink cartridges used here, the flour used here, and the broken dishwasher used on the bridge, we were able to narrow down the cost to the motor, the lights, and in the cardboard.
So budgeting, we tried to use as most recycled materials for our model, and then theoretically in our city, we've tried to make it so government project, and then finally new exports brought more money into our city.
So what role does education play in getting people to buy into this kind of city and leave their suburban homes and gas-guzzling cars and things like that? Did you think about that?
Well, we did think about that. We visited the Chesapeake Bay Foundation, and we were thinking that by the time the city will begin, the Chesapeake Bay will be in such a poor condition, it's already in pretty poor condition, that it's not going to be a very nice place to live. So people will have to learn that what they've been doing has been hurting it, and be able, once they see the actual effects on the bay, almost toxic water, they'll be able to realize that they have to be able to reverse it somehow. And that's our city.
Thank you.